Hello Calc 2 students. In this problem, I would like to give you my advice on evaluating a definite integral that requires trig substitution. Here we want to evaluate the integral from 6 to 10 of the square root of x squared minus 36, all divided by x dx. I will start, as always, by building a right triangle that has acute angle theta. Because I want this radical to be one of the sides, I will label the hypotenuse x and the adjacent side 6. Then the Pythagorean theorem tells me that the opposite side is the square root of x squared minus 36. Now I can read off from my triangle that tangent of theta is equal to the square root of x squared minus 36 divided by 6, and then I can multiply both sides by 6 to see that 6 tangent theta equals that radical. Similarly, I know that secant of theta equals x divided by 6, and multiplying by 6 tells me that x equals 6 secant theta. And finally, differentiating this gives me 6 secant theta tangent theta d theta equals dx. Now I can use the top line to substitute in for this radical. I can use the middle line to substitute for the denominator of my fraction, and the bottom line to substitute for dx. So let's do that. I get, on top of my fraction, 6 times tangent theta. On the bottom of my fraction, 6 times secant theta. And dx becomes 6 secant theta tangent theta d theta. Leave the bounds as x equals 6 to x equals 10. We could, if we wanted, switch these bounds like we do with u substitution, so that instead of using x equals 6 and x equals 10, we have actual values for theta there. But I find that that tends to make things more complicated, so I'm just going to leave it as is. So let's simplify our integrand. We know we can cancel a factor of 6 and a factor of secant theta. This initial 6 we can pull out front. So we have 6 times the integral from x equals 6 to x equals 10 of the function tangent squared theta d theta. Using the Pythagorean identity, I can rewrite tangent squared theta as secant squared theta minus 1. And then I can find the antiderivative of each term. So the antiderivative of secant squared theta is tangent theta, and the antiderivative of 1 is theta. And then I evaluate at x equals 6 and x equals 10. Of course, because these are x values, I can't plug them in for theta. I first need to rewrite theta in terms of x. So I'm going to use this equation where I had x written in terms of theta. So this tells me that secant theta is x divided by 6, and because I don't really want to deal with secant inverse, I'm not really ever sure what to do with that, I'm going to take the reciprocal of both sides and write cosine of theta equals 6 over x. You could also just look at this original triangle and read off adjacent over hypotenuse to get cosine theta. So this tells me that theta is equal to cosine inverse of 6 over x. Okay, so for my antiderivative, I have 6 times tangent of theta is opposite over adjacent, so square root of x squared minus 36 divided by 6 minus theta, this is what we were just working on, is cosine inverse of 6 divided by x. And now I can plug in 6 and 10. So let's do this. I can distribute this 6, and then this 6 on the bottom of this fraction cancels, and this is multiplied by 6. Now plugging in 10, we get the square root of 10 squared minus 36 minus 6 times cosine inverse of 6 divided by 10 minus, now I'm plugging in 6, the square root of 6 squared minus 36 minus 6 times cosine inverse of 6 divided by 6. And simplifying, the square root of 100 minus 36 is the square root of 64, which is 8, minus 6 times cosine inverse of 6 over 10 is 3/5. And then minus, let's see, the square root of 6 squared minus 36 is the square root of 0, which is just 0, minus cosine inverse of 1 is 0. So we end up with 8 minus 6 times cosine inverse of 3/5.